I'm going to work a couple graphing sine and cosine problems for you in this video. The first problem I'm going to work is y equals 1/2 cosine of 3x minus pi over 2. What we'll be doing is using a standard form for the equation of cosine, and it looks like this. Y equals a cosine of bx plus c. And then we could also possibly have the cosine graph shifted up or down, and that would look like this. We'd have another number added outside here. Okay? So this is a general standard form for the equation of our cosine graph. Also, as a reminder, let's just graph the basic y equals cosine of x. Y equals cosine of x. It looks like this. Starts up here at the top at 1, comes down to -1, and then comes back up to 1. And it does that in 2 pi. So 1 period of the graph y equals cosine of x is 2 pi. It starts at 0, 1. This point right here would be, the coordinates of that would be 0 for the x and 1 for the y. And then right here at pi, that's halfway, pi radians, we're down here at -1. So the coordinates of this point would be pi, -1. And then at 2 pi, I could put the coordinates of this point as well, and that would be 2 pi in the x direction, or on the horizontal axis, 2 pi radians, and the y value, the output, would be 1. So in other words, if you plug 0 into cosine of x, the cosine of 0 we know is 1. At pi, the cosine of pi is -1. And at 2 pi, plugging 2 pi in for x, the cosine of 2 pi is +1 again. And we've completed one full cycle of the graph at 2 pi. And the graph keeps going on infinitely in each direction. After 2 pi, it comes back down like this, and it keeps going, and it keeps going on this side as well. But that's one full cycle. I've drawn one full cycle of the graph of y equals cosine of x. So now looking at this one, we have y equals 1/2 cosine of 3x minus pi over 2. So we need to determine what is the amplitude, what's the period, what's the phase shift, is there a vertical shift, and then sketch the graph. The first thing I will find is the amplitude. Amplitude is just the absolute value of a, or it's the absolute value of whatever the number in front of the cosine is, that number right there. So for this problem, the amplitude is just going to be the absolute value of 1/2, or 1/2. And the amplitude tells me how far the graph goes above and below the center line. The center line is this line right here. All right, so this graph of y equals cosine, just a generic one, it goes up to 1 and it goes down to -1. And this graph would have an amplitude of 1 because the number in front of cosine is 1. All right, so I know on my graph the amplitude is just 1/2. It's only going to go up to 1/2 and down to -1/2. So I have a little piece of information about what this graph is going to look like once I know the amplitude. The next thing I want to find is the period. For the period, we do 2 pi divided by b. And b is this number right here. So in our problem, it's 3. So our period for our graph is 2 pi divided by 3. That means that the graph completes one full cycle in 2 pi over 3 radians, or you could think of it as 2/3 pi. So if you look at y equals cosine of x, it takes 2 pi radians to complete one full cycle. Here's pi. 2 pi over 3, 2/3 of pi is about right here. So what this is telling me is that I have the entire cosine graph squished into that much space. Okay, so it goes through one cycle much faster when the period is 2 pi over 3. And I should have put the absolute value of b down here. It didn't matter for this problem, but technically it's actually the absolute value of b. And then the next thing I want to find is the phase shift. And the phase shift just tells me, has my graph been scooted to the left or to the right? This one hasn't. It's going through 0, 1. But if I take the entire graph and just shift it right or shift it left, that's going to give it a phase shift. And to find the phase shift, we look at what is -c over b. Okay, so the phase shift is -c over b. That means that number right there, in this case it's negative pi over 2, is c, and b is 3. So I want the negative of c. My c is negative pi over 2, so this is the negative of c, which is negative pi over 2, divided by b, and b is 3. Alright, so I have negative, negative, and I know that's a positive, because a negative times a negative is a positive. Pi over 2 divided by 3 would be the same thing as pi over 6. I'm dividing by 2 and dividing by 3. Okay, so I have pi over 6. That means my graph is shifted to the right pi over 6 units. So again, looking at your cosine graph, instead of going through here at 0, 1, we're shifting that starting point over to the right pi over 6. To the right. All right, so using all that information, I'm ready to sketch the graph. I don't have any vertical shift. This plus d would basically take the entire graph and shift the whole thing up or shift it down. And I don't have one of those. I don't have anything added over here or in the front. So this graph is not shifted up or down. So no vertical shift. All right, let's put all that information together then and sketch one cycle of the graph. Right, the phase shift is where I start. We want to figure out where do we start, right? What's our starting point? So the first point that you want to graph, your start point, is the phase shift, which is pi over 6. So always start with your phase shift. All right, pi over 6, I'm going to mark that right here. That's my starting point. Where do I start? Well, it has an amplitude of 1/2. So instead of starting, well, before over this one, on this one we started at 0, 1, right? We know the phase shift means I shift that point over pi over 6. And the amplitude of 1/2 means I'm only up at 1/2 and not all the way up at 1. So I'm all the way at the top of my graph, but in this case, that top of the graph point is at 1/2 because our amplitude is 1/2. We're only going up to 1/2 and down to negative 1/2. All right, so that's my starting point. My ending point is the thing I want next. Where does the graph end? Well, it ends once it's completed one full cycle. It doesn't really end there, but that's the last point I'm going to plot because I'm just sketching one cycle of the graph. So the ending point then would be the phase shift plus the period, right? Because it starts here, goes through one cycle, and whatever the phase shift is plus the period, that's going to give me the point where one full cycle ends. So in this problem, the phase shift is pi over 6. The period is 2 pi over 3. So I just add those together to figure out where my last point is in one cycle. You need a common denominator, right? That would be 6. So this would be the same thing as 4 pi over 6. So pi over 6 plus 4 pi over 6 is 5 pi over 6. All right, so pi over 6, 5 pi over 6, I'm going to mark right here. So it completes one full cycle in that much room. And that means it's going to be back up here at 5 pi over 6. Looks like I have a couple stray dots right there. All right, so there's one full cycle. It's going to come down and halfway in between here. It's going to come down to negative 1/2. So this is what the graph looks like then. Well, let's try that again. This is the maximum point. So it's going to go down to there, and it's going to come back up to here. And then it would keep going after that, this way and this way. All right, that middle point, if we want to find that and put what that is, you can just find what's halfway between pi over 6 and 5 pi over 6. And you would have 2 pi over 6, 3 pi over 6, 4 pi over 6, and 5 pi over 6. So this would be, this is 2 pi over 6, this is at 3 pi over 6, or pi over 2, 4 pi over 6, and then 5 pi over 6 is where one full cycle ends. Okay, if you wanted to put the coordinates of these points, this one would be pi over 6 in the x direction, comma 1/2 in the y direction. This point down here would be at 3 pi over 6, or you could also say pi over 2, comma negative 1/2, and it goes down to negative 1/2, and then comes back up to its maximum again right here at 5 pi over 6. And that would be positive 1/2. Okay, so that's how you do that problem. y equals 1/2 cosine of 3x minus pi over 2.